Bijective functions. Put simply, a function is said to be bijective if it is both injective and surjective. In other words, a function is bijective if each element of the codomain is in the image of exactly one element of the domain. The formal definition of a bijective function is given below. Bijective functions. The function f of x equals y is bijective if it is both injective and surjective, i.e. if, for all y is an element of y, there exists exactly one x is an element of x, such that f of x is equal to y. If a function is given by an arrow diagram, then it is bijective if and only if each element of the codomain has exactly one arrow going to it. The diagram opposite shows a bijective function. If a function is given as a set of couples, then it is bijective as long as all the second components are different and we know that there are no other elements in the codomain. So this mapping diagram shows a bijective function, and it is bijective because each element of the codomain has exactly one arrow going to it. So this is y, and each element has exactly one arrow going to it. 3 goes to 4, 1 goes to 6, 2 goes to 9. So each value inside set y has only one arrow going to it, and there are no other values left over that have no arrows going to it. So therefore it is bijective, which means it is injective and also surjective. Show that the function f of r is equal to r of x is equal to 2x minus 1 over 3 is bijective. This means that it is both injective and surjective. So we start off by writing the rule of the function as f of x equals 2x minus 1 over 3, or y equals 2x minus 1 over 3. So we're going to let x1 and x2 be an element of the real number set. So then we have f of x1 is equal to f of x2. So we substitute into our function, swapping the x for x1 on the left of the equal sign and x2 on the right of the equal sign. So we get 2x1 minus 1 over 3 equals 2x2 minus 1 over 3. So we can cancel out the 3's, leaving us with 2x1 minus 1 on the left and 2x2 minus 1 on the right. Then we can cancel out the minus 1's, and then we can cancel out the 2's, leaving us with x1 on the left and x2 on the right. So we get x1 is equal to x2, thus f is injective. Part 2. 2x minus 1 over 3 is equal to y. So this was the rule of our function. Now we want to rearrange to get the x to be the subject of the formula. So we start by multiplying both sides by 3 to get rid of the divide by 3 part. So we get 3y on the right and 2x minus 1 on the left. So what we did was we multiplied both sides by 3. Then we need to rearrange, so we're going to bring the minus 1 over the other side and it becomes plus 1. So get 2x equals 3y plus 1. And then to get rid of that 2, we're going to divide both sides by 2. And we get 3y plus 1 over 2. So now x is the subject of the formula, x is on its own. So for each y element of the real number set, there exists an x element of the real number set, such that x is equal to 3y plus 1 over 2, thus f is surjective. So what that means is no matter what y value we would substitute into our formula, so long as it is a number of the real number set, then the x value that we would get out would also be an element of the real number set. So thus f is surjective. As f is both injective and surjective, it is bijective. An injective function is sometimes referred to as a one-to-one function, i.e. no two elements of the domain have the same image. A surjective function is sometimes referred to as an onto function, i.e. the function maps onto the entire codomain. Then a bijective function may be referred to as a one-to-one and onto function.